Yep. All right, we're only going to get through a portion of this today, but at least we'll get started. They pack a lot of punch in this lesson right here. It's not that difficult. Okay, shh. Listen, please. We've started. Where's your notes? It's not open. Get them open. Ready to take some notes. Come on, be a student. All right, or at least pretend to be like a student. All right. So, what in the world is a determinant? To tell you the truth, I really don't have a good definition for it. I don't even think the book has a definition for it. They just show you how to find the determinant. Okay. It's a word that we're going to use. We're going to use it to solve for x and y when we have a system of equations. Remember that? I mean, we used to do substitution, elimination, and all that. I've been alluding to that, haven't I? I've been talking about that it's going to come, and it is going to come. It's not going to come on today's lesson, but it will show up tomorrow. But you have to know how to do the determinant, all right? The determinant is something that allows us, it's a tool that allows us to do other things, all right? So you got to know how to do the determinant. And it's actually very easy. You can only do the determinant of a square matrix, okay? So a 2x2, 3x3, 4x4. Once you start getting past 3, they get really, really difficult. I don't even think I've ever done one that's past 3, but we're going to today hopefully learn how to do a 2x2 and a 3x3. The 2x2 is very simple, a couple steps. 3x3 is a little bit more involved, but again, it's not too bad. Can somebody get the door, please? All right. So here's how we show a determinant. So let's do this. Here's capital A. That's a matrix, right? But, well, you could just say, Mr. Hamrick, could you move your laptop? Is that better? All right. So, see these two bars? It kind of looks like absolute value. It's not absolute value. It's a matrix inside of here because it's a capital letter. And this means determinant. So these two little bars right here means you're finding the determinant, there's the word, of matrix A. Everybody understand that? All right, so when you see those bars, that automatically means you're finding the determinant of that matrix. Because there's no such thing. All right, so I'm going to start off really general. I'm just going to go A, B, C, D instead of actually putting real numbers in here. We're going to put a number in here in our example, but here's what it would say. All right, it'll say, like, find. Whoops, didn't mean to get rid of all of that. Let's try this again. There we go. All right, so it'll say find, and then it'll just give you this. So what do those two bars mean? The determinant, right. So it might just say find, and then they'll just write this thing right here. Okay, this is how you find the determinants. It's a couple, well, 2 or 3 steps. Not that big of a deal. So everybody watch. We start up here at the top left, and we multiply this way. Everybody got that? And then, I'll tell you what, let's just do that. Turn it back to white. So what would that be if I multiply those together? AD, very good. And then we subtract. We put a minus sign there, okay? And then we multiply this way. Whoops. Like that, all right? So this first one, that's the first one you do. You got to go in order. It matters what order you go in, all right? So we go AD, and then we go minus what? BC. Oops. There we go. And that's how you find the determinant of a 2x2 matrix. Pretty simple. Let's put some numbers in here just to show you how easy it is. So this is an example. Example 1. All right, so it says find the determinant. Yes, Mia.
What is like the point of it? Like, are we using it in another equation?
Yeah, that's what I said. I started off my little talk by saying just finding the determinant really doesn't do much, but it's a tool because we're going to have to find the determinant to find other things. Okay, and you'll see as we do more that finding the determinant is pretty important. To tell you the truth, I'm not a scholar on matrices. Okay, I don't know the history of it or anything else. I guess I could look it up, but I just was never really all that interested. But maybe one day I will look it up. I don't know where it came from. I'm not really sure who came up with it or anything else. but I'm just showing you how to do the problems. That's all you care about anyway, isn't it? Yeah. All right, so if I said find this, what would I do? Yeah, multiply what? 3 times 4 minus 5 times 2. It's as easy as that. That's a 5. It's an ugly 5, but you get the idea. So what do we get? 12 minus 10, which is 2. So it comes out just to a number. It doesn't come out to a matrix. It just comes out to a number. All right? Everybody with me on that? Yeah, I mean, you could put some negatives in here, I guess, but really, would that be much more difficult? No. So a 2 by 2 matrix is really easy to find the determinant of, and we are going to do that. We are going to use that in this lesson a little bit later on. But again, we're we have some time constraints here, so we probably won't do the whole entire lesson. I know for a fact we won't do the whole entire lesson today, but you will have to be able to do the determinant in order to find something else. All right? Now, that was a 2 by 2. What's the next determinant we're going to find? A 3 by 3. So we're going to find a 3 by 3 determinant. This is a little bit more involved. It's not crazy involved, but it is definitely a little bit more than what we just did. All right? So let's just do letters. So it's a 3 by 3. There we go. All right, and it's a determinant, so I'll put these bars next to it, and this is how we do it. First thing I'm going to do is I'm going to rewrite this a little bit. Okay, I'm going to rewrite the whole entire determinant, but I'm going to put some extra stuff in there, and I'll show you that in a second. So let's rewrite this again. So A, B, C, D, E, F, G, H, I. Okay, I'm not putting the determinant thing right there because I'm going to do some stuff with this. Now, don't ask me who came up with this. Don't ask me why. I don't know. I just know that this is how you do it, okay? So what we're going to do is take the first 2 columns, and well, you could use these columns right here, I guess. What we're going to do is take these 2 columns, and we're going to stick it on the end right here. So we're actually going to have 5 columns instead of 3. All right, so take that. What do we got here? Is this going to be A what? A, D, and G. Then we take the second column, which is B, E, and H. Okay? So that's our first little step. Again, I wish I had a good explanation of why we do that. I don't. So look it up on YouTube. Maybe somebody will tell you if you're really interested in that. So here's what we do. You know how we did on that 2 by 2? We did that cross thing, right? Multiplied diagonally. We're going to do the same kind of thing, except we got a little bit more to do. And you're going to see kind of why we put these extra things here. Because if I multiply diagonally, I needed some extra numbers to multiply. Not really the best explanation in the world, but you'll see how it works. So watch. I'm going to multiply those together, right? And then I'm going to multiply these together. See what it's kind of like the 2 by 2, isn't it? Start at the top left, and you go down to the corner. And then we take the third one, and we go like this. Okay? We're going to multiply all 3 of those together, and then we're going to add those 3 up. You got it? All right? So we're not done. We're only halfway done when we do that, okay? I told you it's a little bit more involved. It's not much, but it's a little bit more involved. And then, I'll tell you what, we'll do that step down here. But what I'm going to do now, we're going to subtract. Then we're going to write the same stuff down, the A, B, C, A, B. So let's do that. A, B, C. Let's stretch them out a little bit. A, B, C, A, B. And then what's this one? D, E, F. D, E, F, D, E. And this one is G, H, I, and then a G and a H. Okay? So now what we're going to do, instead of going from the top left, we're going to start at the bottom left and go up diagonally. All right, so what do you think we're going to multiply? G what? G, E, and C. So we're going to multiply those together. Then we move over one, and we're going to multiply H, F, and A together. Chan, are you paying attention at all?
Yeah.
I don't think so. You're not writing anything down. How are you gonna remember this?
I don't know.
Well, I know you're not going to. That's oh goodness. First of all, you're so distracting with wrinkling up that paper. And there we go right there. So that's what we're going to do. Everybody good with that? Yeah. See, we started with bottom left. We just went diagonal, diagonal, diagonal. And we're going to multiply those together and add them up. And then once we get the answer for this, what am I going to do to them? I'm going to subtract them. Okay? So let's do this. This would be what? A, what? E, I plus B, F, G. Now, we're going to have regular numbers in there. Okay? I'm just doing it in general just so you can kind of see the pattern. And what's this going to be? Plus CDH. CDH. So I'm going to figure out what that is. Now, obviously, I can't figure that out because they're all letters and I don't know what they stand for. Put a minus right here. And let's do this. What's this going to be? GEC. So GEC plus HFA. HFA plus, and then IDB. IDB. And that right there is how you figure out the determinant of a 3x3 matrix. I mean, it's a few little steps, but you do them a few times, you'll get really used to it. It's really not that difficult. It's definitely more involved than the 2x2. Would you agree? I think I've seen somebody, or I don't think I ever had to do a 4x4, but I think I saw somebody either on YouTube or somebody showed how to do it, and it was super complicated. I don't even know they did it by hand. It was that complicated. I can't remember. I have to look it up. YouTube at some time. Find the determinant of a 4x4 matrix. All right, and maybe they'll show you how to do it. Because it works. Okay. Yep, this is the way we do it. Like right here, CEG. Yeah, it doesn't matter, right? If you multiply them together, commutative property. Remember that? Doesn't matter what order you multiply things in. Would you agree? So GEC or CEG or ECG, it doesn't make any difference. You're still going to get the same exact number. Okay?
Okay, I'm not asking like, oh, math is stupid, we're never going to use this. I'm actually wondering, like, what do you use this for?
I can't tell you off the top of my head, but I have seen and I have read where people use this. It's like a lot of business kind of stuff. Remember we did that thing before with the, what was it, the scooters or the whatever it was, the snowboards or something like that. Okay, I don't know if this was used for that, but it's things where you have a lot of numbers. It could be like, you know, like salaries. It could be temperatures for something. It could be all kinds of different things, right? And you're organizing them, and you got to figure out how to do stuff. Now, with this right here, remember how we did the 3x3, like the X, Y, and Z, and we had to solve for X, Y, and Z? Remember how complicated that was, and it took half the paper to find X, Y, and Z? We're going to use this, okay, to find X, Y, and Z. All right, so that's one reason for it, okay? Now, why would you ever have to find X, Y, and Z? Why would you have those equations? But again, there are situations in the world, in life. But a high school math class really isn't to explore everything you use it for. It's just to learn the basics, learn the fundamentals. And I think as a high school student, I think if you understand that and you're good with that, and you're like, okay, if I pursue my math, especially if you go into engineering or something like that, if I pursue my math more and more, you're going to look back on this and say, oh, now I know why we did that, because we use this to do something else. And that's what a lot of high school math, I mean, people, just the other day, well, no, this morning, Mr. Clark, remember Mr. Clark? Nope. I'll call him out. The preacher, yeah, with all the tats on him and stuff like that, okay? He used to teach Bible here, and he's preached here once or twice since then. He put something on there, something like, I see this all the time, but he put something like, well, another day went by and I didn't have to know what a rhombus was or something like that. You know what I mean? You see that all the time. And I get it. But there are people out there that need to know what a rhombus is, that all four sides are equal and the diagonals form a right angle and all that stuff that we learn about at rhombus. There are people out there that actually use that stuff. Does everybody? No. But we can't pick and choose in high school what we decide we want to learn because we're not going to use it later or we are going to use it later. You know, you have no idea. We're trying to get a general liberal arts education. When I say liberal, I'm not talking about politically, liberal, conservative. Liberal arts just means a lot of everything, okay? And that's what we're here to do, all right? Maybe you'll use this, maybe you won't. Most likely, you probably won't use this, all right? But there might be some times where it comes in handy. All right, enough of that. Let's do a real one with some numbers. Everybody ready? This is what you signed up for today, right? 2, 1, 3, 5, 3, 4, 7, 2, 6. All right, and I'm going to put the bars. What do the bars indicate? Determinant. We're trying to find the determinant. So it's going to say find. They may in the instructions actually use the word determinant in there, find the determinant, but they could just say find, and if you got the bars right there, that automatically means you're finding the determinant. We good? All right. You know how I separated them right here? I'm gonna not separate them. I'm gonna put these yellow. I could have put those yellow lines right here, couldn't I? Yeah. I just did this first just to not make it look too sloppy. But really, I don't have to rewrite all that stuff again. I could just put my lines here, and all those lines do is just indicate to me what numbers I'm multiplying together. That's all it does. All right. So here's how I would do this. So I'm going to rewrite the matrix. And what's the first thing we do? We got to add a few things to it. What do we do? Add the first two columns. That's right. So I'm going to put a what? 2, 5, 7 right here. And then I'm going to put 1, 3, 2. So make sure you do that. That's pretty important. I'll stay with the same color that we did before. So now we got to figure out what are we going to multiply. Now you may not have to put these lines here. When I did these, when I was taking my notes, right, so that I could teach this to you, I did put the lines there. For me, it's helpful. I remember doing this a long time ago, and I was like, yeah, I like the lines. So I'm going to multiply those, and those. So let's do that first before I go the other way, all right? So we might be able to do some of this in our head, you think? Instead of writing 2 times 3 times 6, let's do it. 2 times 3 is 6 times 6 is 36. Plus, let's do the second one. 1 times 4, that's 4 times 7 is 28. Plus 15 times 2 is 30. So we're going to add those up. We'll do that in the next step. But then what are we going to do going the other way? Subtract. Put a subtraction there. All right? Again, let's stay with the same color system as we did before. So I'm going to multiply this, this, and this. Okay? So let's do the yellow ones. So 7, what's that? 9. 9 sevens is what? 63. Plus, that's 8 and 2 is 16. Make sure you're double checking my arithmetic. All right, and this is 30. All right, let me just double check my math. 36, 28, 30, yep. 63, 16, and 30, yep, that's good. So this came out to be what? 94 minus 109. And then when I do that subtraction, I get negative 15. Okay? And that's the determinant. That's your answer. Really, not that bad, is it? Okay? Now, what we're going to do, let me see. Well, got my notes. Yeah. So we're going to do a thing, again, when we have that X, Y, and Z, X, Y, and Z, X, Y, and Z, 3 of them, we are going to use this. But we're going to use it like 4 times. Yeah, we're going to use it like 4 times in one problem, all right, in order to solve for X, Y, and Z. So does it make it easier than doing it the old-fashioned way, substitution elimination? I don't know. It's kind of the same, tell you the truth, as far as the amount of work involved. But some people would rather not have the X's and the Y's and all that kind of thing, and they don't like the substitution elimination. They get confused. They get lost in the steps. Maybe this is a better way for you to do it. But it's another way. I'm not saying it's a better way. It's just another way to solve for X, Y, and Z, or X and Y when you have those systems of equations. Does that make sense? All right. So we're going to learn a little bit more tomorrow, and we are going to learn a thing called Cramer's rule.
Kramer's rule.
I think they have a little paragraph in the book, if you're interested, about Kramer. I forget off the top of my head. He goes way back. I forget what years he was, but he goes way back, and there you go. So if you want, I'm not going to officially assign the homework tonight. I don't think. Let me see. Did I? I don't know. Let me see. What did I say? Yeah, 1 through 12. Let's do 1 through 12. Look, you're going to have to do it anyway. You might as well just do 1 through 12 right now. You'd rather do that now than do a whole bunch of other problems with it, wouldn't you? Yeah. So that looks like 11, but it's not. It's a 1. It's numbers 1 through 12. And it's section 4.4. You can look, find what page number it is, but it's section 4.4.